Okay guys, so in this video I'm going to demonstrate conservation of energy in a simple scenario where an object is dropped from a height h, let's say. So let's see the video. So what I'm going to do is I'm going to drop the ball, right? And the drop covers a height of 30 centimeters, right? So how do we apply conservation of energy in this case? So you can see that over here, so the ball covers a height h, right? And so h is 30 centimeters, right? Now at the top, the energy of the ball, right, is all potential energy. So E initial is all potential energy, and then E final is all kinetic energy. Right, so this is our zero of potential. There's no potential energy at this point. Now let's look at the energy bar charts, right? That help you visualize how energy changes from one form to another. We're assuming it's a conservative system. There's no energy dissipation. There's no friction or air resistance. We're ignoring that, and it's a good approximation in this scenario. It's very small. Air resistance is going to be very small. So at this point, the bar graph, so let's use blue for potential energy. So at this point, all of the energy is potential energy, right? And there is red for potential energy and then blue for kinetic energy. There's no potential energy because the ball is not moving. And then at somewhere in between, so let's say at around 15 centimeters, right? Half of the energy is potential energy, and then half of it is kinetic energy. Right. And then at the bottom, just before hitting the surface, after it hits the surface, it's no more a conservative system. The ball loses energy because of friction, because of sound. So just before hitting the surface, all of its energy is going to be, so there's no potential energy over here, right? And then all of its energy is going to be kinetic energy. So this is how energy and kinetic and potential are. Well, in this case in particular, we have potential changing into kinetic energy, right? So if you throw the ball up, you're going to get the reverse scenario where kinetic, and it, let's say, goes to the same height. It's going to be the reverse situation where kinetic converts into potential. Now, how do we apply conservation of energy? Initially, the total energy is constant. So E initial is equal to E final. So mgh is equal to half mv squared. So the mass cancels out. So interestingly, the result does not depend on the mass. The mass cancels out of the equation. So in a lot of these questions, therefore, mass is not given, and sometimes students get confused that there's no mass. And the one answer to that is the mass always cancels out typically in these type of questions. So the mass is usually not given. So v squared is 2gh, and v is square root 2gh. So h is 30 centimeters, which is 0.3 meters. If you plug in the number, you get an answer of 2.42 meters per second. So just before hitting the surface, right, the velocity of the ball is 2.42 meters per second. An interesting thing to note over here is that there's obviously a square root, right? So there's going to be a plus minus sign. You have to choose the minus sign yourself, right? So the velocity is going to be negative because the ball is moving down. Now, in this case, also, one more thing to notice is that you can also use the projectile motion equations, right? So we know that the initial velocity is 0, right? You can use the equation v final equals v initial minus gt. So then we now know what v final is, right? So we just get v final equals minus gt, and then v final you can plug in to be negative 2.42 meters per second, and so you get a velocity. So if you plug in the numbers, I think the time turns out to be, let's say, so time is negative. So 2.42 divided by 9.8 meters per second squared, And so let's quickly do that. I'm going to use my calculator. 2.42 divided by 9.8. So you get 0.24 seconds. So that's going to be your time for the ball, right? So the ball took around 0.2 seconds, 24 seconds to cover this height h. And so again, you can always use projectile motion equations, right, to get further insight into the question. Okay, so that was it. Let me know if you have any questions.